Hey boys and girls, welcome to this stupid little video. This video is going to be about making a filter or updating a filter for the coolant reservoir of my CNC router. This is going to be boring if you're not into this kind of stuff. So yeah, if filters for CNC routers is not your thing, come back later. Meanwhile, this is just this is just me trying to document the different things I am going to try based on what I found on the internet that works best. Basically, this is the bucket for my coolant, and this is what I had. This is a mesh, some kind of a mesh. The holes are not, extremely thin, but they're not big either. But I had one like this, and then the pump sits here, and the other one was like this. And what happened was that most of the time, like 99% of the time, it would work just fine, which is good. But the problem is that 1%, when it didn't work, it could really mess up things, because I leave the CNC mill running unattended sometimes. I know you're not supposed to and all that stuff, but when you have like a 10-hour long program, you're gonna leave it unattended. And sometimes you would come back and find out that the pump had clogged because of the chips of aluminum that got into the coolant. And once, if you're calculating or your feeds and speeds to use how do you call it, coolant, when it's a lot, flood coolant, when you're calculating your feeds and speeds to use flood coolant, and all of a sudden that flood coolant goes away, well, basically, yeah, it's gonna be bad. One time I regret not taking a picture or video of it, but basically I was working in aluminium with I think it was a 8mm carbide flute, or end mill, and the thing basically was a solid block of aluminium, a solid stock of aluminium, because it welded all the aluminium in there, and it before it broke, and of course it broke. So the CNC just stayed there working without any end mill in it. Well, anyway, yeah, well, let's get started. I'm sorry I suck at this, but yeah, I just want to get the information out there. It might help someone. A few years back when I was doing this, there was not much information on this stuff on YouTube, or I was dumb enough that I couldn't find it. That's a possibility, but I wish I had a video like this one. So yeah, I'm sorry for sucking at this, but yeah, let's go. Let's see. Okay. Okay, so here we are. I have the camera pointed to the workbench, and well, basically, I want this to be cheap, but most of all, really easy to get if something goes wrong with your filter. I mean, there are probably very good materials for filtration that are going to work better than these. But if when something goes wrong or you need to replace it, you need to have it be shipped, or it will take a long time to get to you. It kind of defeats the purpose. So I want this to use materials that are readily available and cheap. So yeah, after a few digs on the old interweb, I found out that this could work. This is just a Scotch-Brite. Obviously, it's not the brand Scotch-Brite, but I don't even know what this is called. This is, oh, you can see it. You know what this is? I don't know. In English, what do you call this? I have no freaking clue. You use it to wash the pans after your wife yelled at you. This is what you use. Also, there's this. It is also for washing stuff. So what I'm going to test is how fast does the coolant run through these things, and trying to find out the best way to do this, basically, which I still don't know what it is. So I'm going to put this into the bucket, and I am going to put this in here, and I am going to change the camera angle so as to does this work? I guess it just might work. No. All we need is love. All we need is love. Okay, yeah, I guess you can see it. Okay, so now I'm going to pour water in it. So now I'm going to pour water in it and see how fast the water, the coolant, passes through this thing. Wow. Dude, I'm surprised. I did not expect that. Okay, this is good. This coolant I just flushed out of the bucket, and it still had a bunch of chips in it. Yeah, some of these chips are still in here. Okay, so yeah, this is gonna work fine. I don't know how well this will hold up, but I don't see a reason why it shouldn't hold up, because there's not much strain on it, so I don't know. Okay, so yeah, maybe a combination of the two. Maybe a combination of the two will be the best solution here. Let's see. So these on top will, if I put like these on top, they will hold on to the bigger chips, and then the one in the bottom will filter out the rest of the stuff. Let me get some more here. By the way, these were 1.2 euros each, or $20. I don't know how much the dollar is worth these days, so just kidding, calm down, everything's fine, it's just a joke. This kind of looks like a rat's nest. I need a couple more. Put a couple more here. Well, you get the point. So yeah, this is not the finished thing, but yeah, I have enough for it to be all over, to get good coverage. So water will come in here. And it will filter down. Okay, good. Now there's, oh, I wish there was a way I could check if, okay, this is not easy to pull out. hopefully it's not gonna be coming off anytime soon. There's not much water in this once you remove it. Okay, so now how do I check if, I know. So I am going to pour the coolant in this transparent bucket so that I can check. Why is it taking so long? Wow. I had pressure over there. There's a good seal. Let's see. Okay, there are no chips over there. I did clean the coolant reservoir beforehand, and I am just let this thing rest for a bit and see if there's some kind of chip sediment or something, or if the filter worked good. I believe it worked way better than just the wire net. Okay, so I'm going to add more. Okay, this is not so good. Okay, that's fine. So what I'm going to do is I'm going to cut this in such a way. Actually, I don't even care. As long as it stays in range of, because you see, the thing is, I don't want, let's put this to the side. I don't want the water, let's think ahead, and if this begins to build up chips, the water is gonna obviously go the easiest way, and it's gonna spill to the side and get in to the coolant without passing through the screen stuff. So yeah, I'm gonna put it like this so that it makes a little puddle, and it should prevent that from happening. Maybe, I don't know. Okay, I'm just gonna wedge it in there. Kind of wedged. If you're wondering if flood coolant is really necessary, there are a lot of opinions on that. And mine is yes, definitely. It's definitely necessary. Can you mill without it? Sure, you can. Can you have sex without a woman? Or a man for that matter? Or what the fuck am I saying? Let's cut this to size. Back to the subject at hand. Can you mill without flood coolant? Yes, you can, but you're just making your life harder. It's much, if you have good coolant, it's much easier to get good results and consistent results if you're using coolant. That's what I found. By the way, I'll show you the coolant I'm using. So yeah, this is what I have. And this was 37.65 euros, but well, I don't know much about it. I just know it works really well. This is supposed to be mixed. I think it's at a 5% of coolant, and yeah, this is great value because you just add a little bit. Now this thing is brown. See, like this. But when you mix it in with the water, it becomes white. That's why some people call it, I think, white water, maybe. Okay, so this is what we have so far. I'm making a mess. Okay, so I'm going to put this back on and fill it with those things. Okay, that's a small issue. This stuff actually molds really well to the net and to the bucket. I did not expect that. So as I said in the beginning of the video, this is just me testing out a new type of filter. Yeah, no chips are going to pass easily through here. Now also, I don't think it's going to get clogged that easy because there's a lot of surface here that works to catch the chip before it reaches that green stuff. And also, most of the chips stay in the mill bed, in the CNC bed. They don't go down. Some of them go, but because of obviously there's a large stream of water running down into this bucket. But yeah, that's whatever. I will probably make a video if you guys want an update on this. In a few weeks, just leave a comment below now saying, I want to know how this worked out. If there's people watching and they want to know how this worked out, I will make a video showing how good it worked or how bad it worked or how catastrophic my ways are. However, if there's nobody watching, which is possible, I probably won't bother. So if you want to know how this works out, be sure to leave your comment below and just say, hey asshole, make the damn video, don't be lazy. What do you think so far? This looks good. I like this. Yeah. Looks to me like we're gonna catch a lot of chips in here. So, okay, let's try this on for size. Oh yeah, that's going... Ah, damn it, and I agitated this. Yeah, but there's no chips, there are no chips in here. Of course, after passing through that green stuff, that's amazing. Scotch-Brite or Scotch-Brite or whatever it is. Okay, let's install this under the machine. Okay, this is what you see under my router. And the way this works is pretty simple. Let me get this out of the way. Maybe. Okay. So the router is on top of this bench, and this is the through hole through the bench where the coolant comes in. Now this is press fitted like this in here, and I am using a very small but very powerful this thing. This is one of those pumps that you have on your car for the wiper fluid. This thing can run for hours and not get warm because it has coolant passing through it, which is good. It can shoot the water along a great distance of a pipe because it was designed for that. Remember, in your car, this sits in the front in a small reservoir, and it can shoot the water all the way up to your windshield, and it can shoot it back sometimes to the rear window. So it works really good and it has great pressure for clearing the chips. This I like it. Best thing about this is you can find hundreds of them in like a junkyard, and they're cheap. Nobody wants much money for these. So yeah, this is my great tip on it. This little guy, it works. This one is here for years now, and I have like 5 more that I bought just in case this went wrong. Never went wrong on me. Well, now as you can see in my system, the hole to get the water out is not right on the bottom, because if something gets in, you want to have a clearance to not be picking up all the dust on there. And this has like a rubber gasket. Yeah, that happened. And you just put it here. Okay, there you go. We're all done. Also, I have air attachment here, so I can use air and coolant at my discretion. So yeah, let me just get a thing here, bench. And let's fill this thing up. So to fill it up, I just take it out of its housing, put it on top of the bench, and I have pre-mixed flood coolant here. So yeah, let's do this. Yeah, I don't want it to tip over, so. Now, you want to make sure when you have a system like this that you have plenty of coolant. The reason being, once the coolant starts getting shut up into the CNC router or CNC mill, you are going to have a lot of coolant that it's not going to be in here. And it takes a while for it to travel through all the system and get back into the bucket. So you need a lot of coolant just to make sure that you are not going to run out. Okay. You're good to go. That's very nice. Let me just transfer this coolant here. Let's go over to the top. Okay, so we're on top now. This is my cute little mill. Built it myself. Works quite well. Nevertheless, that's not the point of this video. So yeah, this is where the coolant comes in. This is where the air comes in, and back there, you can see it right there, is where the coolant goes back out. Now in here, this is quite a large reservoir, so some of the water is going to puddle in here for some time before it goes back into the pan. That's why I was saying that you need a lot of water, because you need to be able to fill this. It doesn't get too high, but you know what I mean. You need to have enough water so that it can come here, and then you still have water in the reservoir, so you can cycle the water through. I'm going to turn the flood coolant on. Let me just get here to machine settings, actually on programs, and here you go. As you can see, that's quite a lot of coolant. When you have let me turn this off. Actually, no. Let's see how long it takes before the water reaches this point here, where it needs to reach until it starts going back into the pan. Let's imagine it's working. Yeah, those are my special effects. Right, there you go. We just reached it. Yeah, you see? So, as you can see, it doesn't puddle much, but it needs to have enough so that it can do this all day. So it needs to have an excess. Okay, so I guess this is it. Want to see something cool? Boom! It was not attached. You thought you were going to see a crash, but you did not. I fooled you. Okay, so this is it for this video. If you have any questions, just, you know, ask. And yeah, this is, I guess this filter is going to work pretty well. Once again, if you require an update to see if this filter worked out, just ask in the comments down below, and I will let you know in a week, 2 weeks, 3 weeks, how did it go. Maybe that green stuff will dissolve and start spewing green stuff through the coolant, and then it will get cut up in the carbide end mills, and maybe the world will explode because of it, or maybe it will be just fine. And yeah, so just one more thing, guys. I realized while I was looking at the viewfinder, this is not what it looks. What do I mean by that? When you're looking at that spindle, it looks like one of those Chinese-made spindles. Let me assure you, it is actually not. This has a proper motor and a proper spindle in here. So yeah, just wanted to let you know, because someone might be seeing this, and when I say, oh no, this works fine, it cuts good, and they might think that it has one of those VFD driven 400 hertz or something spindles that run at 24,000 RPM, and hey, they work. The thing is, they cannot hold a torque for shit. I had one of those, and that's where this spindle holder plate thingy comes from, because that was good, that worked fine, and it's rigid. But then I milled that center part with the 4 tapered rolling bearings in there, and then there's the thing that goes to the, well, I changed it. Why? Because you do not always want to be machining at 5,000, 10,000 RPM. You just don't. And because even though that you have the speed, you might not have what it takes to machine at those speeds. And if you slow down the machine, what's going to, well, the problem is that if you have the machine running at 10,000 RPM and you're going slow because you have a vibration issue, or because you can't go faster because the spindle does not have the horsepower to take care of the material, what you're going to be ending up doing is rubbing. You're going to rub your tool against the workpiece, and you're going to wear your tool in no time whatsoever. And on the other hand, if you slow it down, if you slow it like to 3,000, 4,000 RPM, those spindles, they don't hold the torque. So you can't work with them, actually. They are great for routers that work on wood or something, or for little engraving stuff, but for real machining parts, like, you know, you can't use them. That's my opinion. If you have one of those, please don't get all hot and bothered if you have a different opinion. But I suspect that if you have one of those and you tried a system where you can have more horsepower at lower RPM, you probably know as well as I do that more horsepower, lower RPM works way better. You get nice consistent chips and that power, and you know you're not going to stall. That's much better. Well, yeah, this is getting to be a long video, a long stupid little video. So yeah, thanks for watching. Any questions? Totally available. to ignore you. Just kidding, just kidding. See you later, guys.